Hello everybody. I'm back with another video for you today. Our focus is going to be on like terms. Our goal today is just going to be able to identify like terms. Coming up, we'll being able to combine them, but for today we just want to focus on being able to identify a like term. So I guess the first thing I need to do is introduce to you and get you to understand what a like term is. Okay, if you look at my definition here of a like term, it says it is terms that have the same variable and also have the same power or exponent, in other words. So there's two parts to this. It has to have the same variable and it has to have the same power. Okay, now variable and terms are words we focused on yesterday. If you remember, your variable is a letter that usually represents a number of some sort, but it's a letter, okay? And terms were the parts that are being added and subtracted, okay? So if we're talking about a variable, okay, if I had 3n, right, there's my variable of n, it would be considered a like term if I had one that said 2n, right? Because it has the same variable, n and n, and it has the same exponent. Really, it doesn't have any right now, right? So they are the same. We are not concerned about the coefficients. The coefficients do not have to be the same. So it is okay that this is a 2 and this is a 3. Okay? All we are concerned about is that do they have the same variable and do they have the same power? Now, if I change this to an exponent of 4, in order for this to be a like term, it also has to have an exponent of 4. Right? It still has the same variable and it has the same power or exponent. The number in front does not matter. Okay, so let's look at some examples of things that are like terms and then some that are not. Okay, on this screen, to the left of this red line is some examples of items that are like terms. We'll talk about the right in a second, which is those that are not. But let's look at the left. So remember, in order to be a like term, it has to have the same variable and power. Those are the two things that we are looking for. Okay, so look at 3 and n. It has the same variable and power, right? There is none, so that's a like term. Again, we're not worried about the number or the coefficient in front. Looking at this one, 8y and y are like terms. They have the same variable and they have the same power. Right? Negative 6k and 9k, same variable and same power. There isn't any. Now, don't let it throw you that one's negative and positive. We do not care about this number in front. We're only looking at variables and we're looking at the exponents. Same with this one. They both have a d as their variable and there is no exponent, so they are the same. It does not matter that this is a fraction and this is a decimal. We don't care about that. Okay? The constants, remember these are constants, numbers alone, they have the same variable, right? There isn't any, and they also have the same power. There isn't any. So these are like terms. Looking at this one, negative 2s to the fourth and 9s to the fourth. They have the same variable. They're both s's. And they both have the same power or exponent, which is 4. So that is a like term. And finally, if we look at this one has a c to the third, and so does this one. And this one has a z to the second, and so does this one. The order doesn't matter, right? Because all that means is multiply. It doesn't matter what order they're multiplied in. So as long as the variables are the same and the exponents are the same, they are like terms. Okay, so now let's look at some examples of things that are not like terms. And I think this one's pretty obvious, right? Because this is a C and this is a J. They are not like terms. They do not have the same variable. Okay, going to this one, 2b to the second and 5b. They are not like terms. Yes, the variable is the same, but the exponents are different. This one has a 2 as an exponent, and this one does not. Okay, so both parts have to be the same for a like term, same variable and exponent. This one only meets one of those requirements. It does not meet the exponent requirement. Okay, let's go down to this one. 4a to the third, d to the second. So when we go down here, look at the a. The a down here is to the second, whereas this one's to the third. And this one has d to the second and d to the third. So they are not the same. Do they have the same variables? Yes. But the exponents for both examples here are not the same. So it is not a like term. Okay, and let's look at this one. 4mn and 5ma. Okay, these are not like terms. The variables are not the same. This is an m and an n, this is an m and an a, so it would not be a like term. Okay, so it has to meet both conditions, same variable and the exact same power. Okay, let's try something else. All right, so this says identify like terms. Okay, this is something I usually like to do in class, but we don't have that option right now. So we're going to move together and match up some of the like terms. You may find some that don't have a match, and that's fine, but let's see what we can match up. So the first one over here says 8x. So I'm looking to see if there's anything that could be a like term with 8x. Remember, it has to have the same variable and exponent. So there is no exponent. So I need something that's a plain x. And it looks like this one would match, right? These two would probably go together. Same variable, same exponent. Okay, so let me try. How about if I try this 5x to the third? So now I need, same variable, I need something that is x to the third. Well, if I look over here, I see an x to the third. So I would think that these two go together. Okay, I'm going to go way over here, and this one says 4y to the third. So I need something that matches with y to the third, a y to the third power. And if I look, I see this one, right? So I think these two go together. Okay. Let me move this around a little bit here, make some room. How about this one? It says 3a. So I need to find something that has an a and no exponent. And I believe this one matches up. Right? A and no exponent. It does not matter if one's positive and negative. We don't care. All we would need is the letter and the variable. Okay? So how about 7a to the second and b? Okay, so I need something that has an a to the second power and a b. And if I look, this one has an a to the second power and a b. So again, doesn't matter that is negative. We are okay with that. This one says 8z. So no exponent. So I need a z with no exponent. And I believe these two would go together. Okay. And lastly, I have a 5ab. So I'm looking for an a and a b with no exponent. So this one seems to go with it. And whether or not you realized it, this one goes with it. It has a b with no exponent and an a with no exponent. So they match up. So this one has a group of 3, and this one down here does not match with anything. Okay? So there are my like terms that are matching up. Okay, now that we know what a like term is and are able to pick them out, we're going to take the next step here. And the next step is we need to identify them in a problem and be able to match up anything that is a like term. So let's say, for example, this first thing in my expression here says 6r. So I need to see if there's anything else in this expression that would be a like term with 6r. So an r with no variable. So I see this one is an r with no variable. So we need to mark them so that we can tell they go together. So I'm going to put a circle around them. Now, the one thing I want you to get into a habit of is including the sign in your marking. Okay? So this is minus 2r. So not only am I going to circle the 2r, but I want to circle the sign to the left. Okay, to the left of it. Now the 6r, because it's the first thing in the problem, does not have the sign, and that's okay. But if there's a sign to the left, circle it. That's a great habit to have for when we do the next step tomorrow, okay? So those two go together, so I circled them, okay? And you could do triangles, you can do underlines, some of you use highlighters, whatever you like to do to show that those two go together, because we're gonna have other ones that go together, so we need to be able to differentiate. So let's look at this one. I need a 7r to the second. So to match it up, I need to find something else that has r to the second, and I see it here. Okay, so maybe I put a rectangle around this one. And remember, include the sign to the left. So I'm going to put a rectangle around the plus sign there, and then this. And over here, I'm going, again, including the sign to the left, which is minus, down to r to the second. So there's my rectangle. So I can easily tell these two go together, and so do these two. And then lastly, what do I have? I have a constant of 9, and I also have another constant. So these two go together. So maybe instead of making a shape, maybe I'm just going to underline this one and underline this one. Okay, so I can easily look at this and see that these two go together, so do these, and so do these. Those are my like terms. Okay, let's look at another one. Okay, so we have another expression here, and our job is to identify and somehow mark the like terms that go together. So you can start anywhere in this problem, but I'm just going to start at the front, and I see one that says 10x. So I need to look for another one that has an x with no variable, right? Because it has to have the same letter and exponent. So I need an x with no variable, or with no power, sorry. And it looks like this one. So these two go together. So again, maybe I underline them. Again, include the sign to the front, but this 10 does not have a sign, but the 2x does. So I'm going to include that one. All right, so let's find something else. I see a 4y. So I need something else that has a y with no variable, and I see it here at the end. So now we're going to mark those. So maybe you use, I don't know, 2 lines instead of 1. Maybe that's how you mark that they go together. I'm just trying to show you some different examples. Okay? And then the one here that is left is 3x to the second, and I don't see anything else that has an x to the second power, right? These don't have any. So this one goes by itself. Okay, so maybe I just give this one some sort of a squiggly line or something to know that that one is by itself. But again, I can easily identify which ones go together, and that we will need for tomorrow. Okay, let's look at one last problem here. Okay, and we're going to identify our like terms. So if we look at this, there's a lot of A's and B's on this. So we have to be very careful about which ones go together, because it has to have the same variable and exponent. So I'm going to start at the beginning. And I have a 4AB, and neither of the A or the B has an exponent. Okay, so that's what I need to look for. And I see another one, an A and a B, that do not have an exponent. So maybe I put a square around these. If you have highlighters, you're more than welcome to highlight them too. That works. And again, I'm including the sign to the left. Get in that habit, please. It will be very valuable to you. Okay, so I've circled or marked those two. Let's look at the next one. This has an AB also, but it has an A to the second and a B. So I need to see if there's anything that has an A to the second power and then a plain B. And if I look, I think this one does, right? So I need to mark that. So maybe I am just going to draw a line under this one. Include the sign to the left, right? A to the second B. This one has an A to the second B. Okay, this one does not work because in this problem, it is B to the second, not A to the second. So be very careful about little details. Make sure those little details work for you. Okay, So if I move through my problem, the next thing I have is a constant. So I'm looking for another constant that would go together, and it looks like this one. So maybe I circle this, and and again include the sign to the left, and the same with this one. Okay, it looks like I have one left, and that is AB to the second. I don't see anything that has an exponent of 2 on the B. So it looks like this one is all by itself. Okay, so maybe in this one, excuse me, I underline this one twice or something, or even 3 times, so that I know that that is different from the rest. Okay, so your goal here today is to know what is and is not a like term. We need to know that, and to be able to identify them, somehow mark them within an expression. Okay, and then we'll add to this tomorrow. All right, there is some practice for you to do on Schoology. So good luck with that. If you need anything, please send me a message.